Welcome back to the course on symmetry, stereochemistry and applications. In this lecture, we will continue our discussion on the nomenclature of organic compounds. In the previous lecture, we were discussing about the nomenclature of compounds derived from the carboxylic acid. So, here we will continue that discussion. So, when you are trying to name the derivatives of carboxylic acids, as we all know that carboxylic acids are written as oic acids, as you can see here, and when we convert that benzoic acid or any carboxylic acid to the corresponding ester, we write it as OATE, OAT. So, carboxylic acid becomes carboxylate. So, ethyl acid, ethanoic acid becomes ethyl ethanoate or methyl ethanoate and things like that. So, in this case here in the example that I have written is that you have one carboxylic acid which is originating from an acid containing 2 carbons. So, it was ethanoic acid, but then I have a methyl group which is connected to the oxygen. So, then it is the methyl ester of ethanoic acid. So, the name should be methyl ethanoate. Similarly, when you have the next acid which is shown here has 3 carbon atoms. So, this one is originating from propanoic acid. So, it becomes, when it is ester, the name becomes propanoate, and this signifies the corresponding ester part which has come from an alcohol which is ethyl alcohol. So, from ethyl alcohol it has got generated. So, we write it as ethyl propanoate. The next type of acid derivative is the amide, which is also originated from benzoic acid or any organic acid. So, with oic acid getting converted to amide, we write the name as amide. So, here in the first example, once again it is originated from ethanoic acid. So, we write it as ethanamide, and it depends what group is here. So, depending on that it is N methyl, because on N I have a methyl group present. So, instead of methyl group, if you had 2 methyl groups, as you can see here, we should write it as NN dimethyl ethanamide. So, this is how one should start naming the amides. So, we have been talking about amines and amides and all that. In that discussion, we have already discussed that there are possibilities of compounds called amines. So, here I want to discuss quickly what are amines. Amines are derivatives of ammonia. So, from ammonia, if you replace one hydrogen by an alkyl group, it becomes a primary amine. You replace 2 hydrogens with 2 alkyl groups, then it becomes a secondary amine, and the third hydrogen if you replace with a third alkyl group or aryl group, it becomes a tertiary amine. So, these 3 different types of amines respond to different types of tests, which we will learn in a different course. So, when you talk about the amines, the naming comes from the corresponding hydrocarbon. We first need to identify the long chain hydrocarbon from which it comes, and the amino group is always treated as the principal functional group and expressed as suffix. So, here this E is replaced by amine. So, for example, what are the names of these 3 compounds? The first compound is coming from a single carbon compound, methane. So, instead of writing methane E amine, we drop that particular E and written as methanamine. Similarly, the next one is ethenamine or ethylenamine, because this group is a double bond containing group. So, ethenamine. And the third one, as you could see, that has a C triple bond C. So, it originates from ethyne. So, the last E is again dropped and amine is added at the end. So, it is called ethenamine. So, when you have multiple functional groups, we can name the amines with functional groups other than C triple bond C, CC, double bond, halogen and alkoxy groups. So, the amino group is always treated as the substituent and expressed as a suffix, and amino is coming, it comes when you have a molecule like that, which has two functional groups at two ends, OH and NH2. OH has a higher priority. So, the compound is ethanol, where this part signifies the ethane, this part talks about all, and at 2 position you have the amine group. So, we write it as 2-amino ethanol. There are possibilities of aromatic amines. So, here we do not write as benzene amine, rather we write phenylamine, because the group which is C6H5 is the phenyl group. We have a specific name for that called aniline. Similarly, when you have multiple substitutions, you start numbering them following the same method that we have discussed in the previous lectures, and apply the numbers and then write the corresponding names. So, in the first case it is 2-methyl aniline, second case it is 3-methyl aniline, and fourth case it is 4-methyl aniline. These are the common names of those three compounds. Those are respectively orthotoluidine, metatoluidine and paratoluidine. Now, you see the difference. These two compounds which are drawn on the left hand side have the same molecular formula, but the position of methyl group is different. So, in the first case the methyl group is connected to the aromatic ring. So, it is named as 2-methyl aniline, and this nitrogen is 1 degree, that is, it is a primary amine. But when the methyl group is now connected to that nitrogen, we write it as N-methyl aniline, and that N, the nitrogen here is a secondary nitrogen. That means, this N-methyl aniline is a secondary amine. In this case, we should not write as N-phenyl methanamine, because this chain is, this ring is the major ring, which is the phenyl ring. So, what would be the names of these three amines? We should start numbering them as usual. So, we should number in such a way that amine gets the lowest priority over double bond, and then try to write the name. In this case, it is 1 amine, because at one position it is NH2, and the compound is derived from propane, and there is propene, and there is a CC double bond between 2 and 3. So, we write it as prop 2 in 1 amine. The second compound is named as prop 1 in 2 amine. Why? Because now, if you write if you try to number it in any direction from one left to right or right to left, NH2 group always appears at number 2. But now, if you write it from left to right, the in comes at number 1 position. Therefore, it should be written as prop 1 in 2-amine. And the third one, you see here what we have is a 4-membered chain, 1, 2, 3 and 4. So, we have 2 amino groups. So, it must be diamine. We write it as 1,2-diamine, and this being a derivative of butane, rather butine, we have a CC triple bond. So, we write it as 3-ine. So, the name directly signifies a particular molecule which is shown here. Now, let us see how do we name this kind of a molecule. What can we see in this molecule? We have CC single bond in the middle in this red circle. So, on that we have a nitrogen. So, it is called ethane amine. Then what we have is on this nitrogen we have ethyl group, and then there is a methoxy group, and also there is another N-methyl group. So, what should be the name of this compound? The name of this compound should be N-ethyl 2-methoxy N-methyl ethanamine. Now, you see here what we are trying to follow is the alphabetical order of those substitutions ethyl, methoxy and methyl once again. So, this one has to remember that after identifying the longest chain, you should find out the substitutions, and once you are sure about the substitutions, then try to write those substitutions in the alphabetical manner to get the name of the compound. So, applying the same logic, what should be the name of this compound? If we carefully see that the longest chain is now different, it is not the central CC bond which was the earlier case, but in this case the side chain with 3 carbon atom is the longest chain. So, it is a derivative of propane 1-amine. What we have is 1,2, that is ethane. So, what we should write is that the nitrogen is attached to a 2-methoxy ethyl. This is methoxy group connected to 2 position. So, it is 2-methoxy ethyl that is connected to nitrogen, and then we have N-methyl substitution on the left. So, altogether the name should be N,2-methoxy ethyl N-methyl propane 1-amine. So, once again you see here we are following the rules that we have learned from the very first class. We need to identify the longest chain, we need to identify the substituents, and then write the name with the alphabetization of the substitutions. The next set of molecules are called the nitriles, which contains a C triple bond N group. This can be of 2 types. If it is acting as a principal functional group, it is expressed as the suffix nitrile, and if it is acting as a substituent, it is expressed as a prefix cyano. So, let us see these 2 cases one after another. So, here we have 2 compounds which are written as ethanonitrile and 2-methyl propane nitrile, because in both the cases the cyano group is the only substitution or only functional group. The carbon of the CN group is counted as a part of the longest carbon chain in these 2 cases, and the CN group always occupies the terminal position, just like the condition with aldehyde or carboxylic acid. So, we do not need to mention the position of this particular CN group. But now, when we have molecules like this, where you have hydroxyl group and cyanide, or carboxylic acid with a cyanide group. So, we first name them, number them, find the longest chain and apply the numbers, and then try to write the name. So, in this case, the first case you have hydroxy group at position 4. So, we write it as 4 hydroxy pentane nitrile. In the second case, we write these numbers as 1, 2 and 3 and do not count that fourth one, and write it as propanoic acid, that is the beginning, and then we have a methyl substitution at 2 position and cyano substitution at 3 position. So, we write the total name as 3-cyano 2-methyl propanoic acid. So, here you can see the priority of cyanide is lower than the priority of carboxylic acid. So, in those cases, the cyanide group is written as cyano, not as nitrile, but when the cyanide group is the principal group, we write it as nitrile. So, if used as a prefix, its carbon is not counted as a part of the main carbon chain, which is done here. There are many organic compounds which has more than one functional groups, may be same or different. So, they should be named in that way. So, here we have a dicarboxylic acid which is commonly known as oxalic acid. Its IUPAC name would be ethane dioic acid. The second compound has 5 carbon chain, and that 5 carbon chain is named as pentane, and we have 2 aldehyde groups at 2 terminals. So, we write it as pentane dial. CO2H and CHO groups always occupy the terminal position, which is always to be remembered. So, we do not need to specify their position when we are trying to write their names. So, when we have polyfunctional compounds with different functional groups, we need to prioritize them, and we need to write them as per their class. So, here the first case is a carboxylic acid with amine. So, the carboxylic acid is written as oic acid. It is originating from ethane. So, it is ethanoic acid, and then you have the amino group present, which is a 2-amino substitution. So, the name appears as 2-amino ethanoic acid, or the common name is glycine. The second one is 2-hydroxypropanoic acid. Again, here the acid is a 3-membered ring, 3-membered chain. So, it is propanoic acid, and the substitution is 2-hydroxy. So, when we try to write the priority order for different functional groups, we need to remember this particular flow, that which comes above what. So, I would like all of you to pay attention to this chart and remember their priority, and based on this priority, the names of those organic compounds will be determined. In the next few minutes, we will try to understand the bicyclic compounds, the nomenclature of these compounds. Bicyclic compounds are those that contain 2 or more rings. Bicyclic compounds are those that contain 2 rings. There are 2 different types of bicyclic compounds: 2 rings with 1 common atom, the spiro systems, which is example here; 2 rings with 2 common atoms, and those 2 common atoms are connected together, called the fused ring systems. This is one such example. And 2 rings with more than 2 common atoms, and the common atoms are not connected, they are called the bridged systems. So, this is called that the bridge system that you have here. So, when we try to name these bicyclic compounds, these three different types need to be addressed in a different way. In case of the first type, spiro ring system, the smaller ring is numbered first, and then through the common atom the other ring is numbered in such a way that all the substituents gets lower priority. So, you write it as 1, 2, 3, 4, 5, 6, 7, 8, the number of atoms present in the smaller ring and the number of atoms present in the bigger ring, and this has 8 carbon atoms. So, it is octane. So, we write it as spiro 3,4 octane. The second one here that we have is numbered like that 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So, this is a derivative of decane. It is a spiro compound, and then on the left hand side ring you have 4 carbon atoms, and the right hand side has 5 carbon atoms. So, let us talk about the fourth example. Third one I am leaving for you to understand yourself. The fourth example I am numbering in this way 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here you see the numbering has done in such a way that this functional group here gets the lowest number. Here the substitution also gets the lowest number. So, this becomes octane, decane 2-one, because you have ketone at 2 position, and then it is a spiro compound, and there are 1, 2, 3, 4 atoms on the left side ring and 5 atoms in the right side ring. So, 4.5, and the dimethyl appears at 7 position. So, we write it as 7,7 dimethyl spiro 4,5 decane 2-one. These numbers are represented in square brackets. So, always we start the numbering from the first atom after the common atom. So, when we come to the next type, which is fused ring systems, there are common atoms that are called bridged atoms. There are 3 paths between the 2 bridged atoms. Longer path is numbered first, and then the shorter path, and then the shortest, and always the numbering starts at bridged. In case of this system, the shortest path has direct contact, and hence the number of atoms between them, that is the 2 bridged atom, is 0. So, the way we write their name is shown here. In the first case, we write it as 1, 2, 3, 4 and then 5. So, there are 2 atoms between 1 and 4 on this side. There is 1 atom between 1 and 4 on that side, and 1 and 4 are directly connected. So, we write it as bicyclo 2.1.0 pentane. Similarly, the last one that you have here is numbered as 1, 2, 3, 4, 5, 6, 7. So, the largest ring is numbered first, and then goes on the other side 8, 9, 10. So, it is written as bicyclo, decane, and these numbers 5 is the number of atoms in the largest ring, then the number of atoms in the smaller ring, and 0 indicates that these 2 atoms are bonded together. The third type of bicyclic compound is the bridged ring system. So, here the common atoms are called bridged atoms. There are 3 paths between the 2 bridged atoms. The longer path is numbered first, and then the shorter path, and then the shortest path. The numbering starts at bridged. So, in case of this system, the shortest path does not have direct contact, and hence the number of atoms between the 2 bridged atoms is variable. So, here when you try to write these names, we should again write it as bicyclo. and hexane. As you can see, there are 6 atoms here in this particular molecule, and we have 2 atoms on that ring. So, it is 2, 1 atom here between these 2 on that ring, it is 1, and 1 atom there, it is 1. So, in the same manner, the third one here we can see that it has 2 bridgehead atoms. We start numbering from one of them, number it in the longest ring first and then the shorter ring, and then we write it as octane because there are 8 carbon atoms. And then from 1 to 5 we have 3 atoms here. From 1 to 5 on that side you have 2 atoms, and from 1 to 5 through 8 we have 1 atom. So, we write it as bicyclo 3.2.1 octane. This is how you should number these bicyclic compounds. These are some other examples of bicyclic compounds that you may want to learn yourself how these namings are done. The last type of compounds that I would like to touch on are the compounds which contains atoms other than carbon, hydrogen, nitrogen, oxygen. See, for example, boron, silicon, phosphorus, etc. So, when you have this kind of substitutions, we have different prefixes for different elements, and here is one example which is a very well known compound DABCO used in polymerization reaction. This is nothing but a bicyclic compound containing the heteroatoms. So, we write it as bicyclo 222 octane if it was just carbon, but then at 1 and 4 you have nitrogen. So, we write it as 1,4 diaza bicyclo 222 octane. Similarly, DBU is another compound which is used as a catalyst and complexing agent, and this compound falls as another bicyclic compound where the 2 common atoms are joined together, joined by a bond. So, the name is similar, bicyclo 540 octane, because this side you have 5 atoms, on the other side you have 4 atoms, and the bonds is there between the 2 atoms. So, it is bicyclo 540 undecane, 7 in because you have double bond at 7 position, and there are 2 aza groups. So, we write diaza 18 diaza. So, like this we can we can name all kinds of molecules that we may encounter in this course. So, with this I would like to end the part of this course where we talked about the IUPAC nomenclature of organic compounds.